Before we continue looking at renewable energy sources, we're going to look at a coal-fired power plant, or a more traditional type of power plant. And the reason for this is there's a lot of similarities between a traditional power plant and things such as our biomass power plants. So first of all, we're going to try to understand how a traditional power plant works so that we can incorporate some of those concepts when we look at biomass power plants. So here we have a diagram of a traditional power plant, and over on the left-hand side, we have our coal. Now we know that in a traditional power plant, we're burning coal to produce electricity, but there's a process that has to happen in order for that to occur. Now coal contains a huge amount of energy, and what we need to do is release that energy, but turn it into a workable form. And the way that we do that is by taking water and turning it into superheated steam. So in the centre here, we have a furnace, and within that furnace, we have a heat exchange taking place between the burning coal, which is releasing a huge amount of heat energy, and our water. Now it's important to note that what we have here for the water and the steam is a closed system. So we have the water entering our boiler. It travels through the boiler where it becomes steam, but then we continue to heat that steam and we get what's called superheated steam, which is very hot, very high pressure steam. And the superheated steam is going to exit from our boiler. Now that superheated steam contains a huge amount of energy in the form of what we call enthalpy. And what we need to do is recover that energy or recover that enthalpy in order to produce mechanical work. And the way that we do that is using something called a steam turbine. So pictured here, we have our steam turbine. Now entering that turbine, we have steam which has an incredibly high temperature and an incredibly high pressure. And what the turbine does is it expands that steam. Now when we expand the steam, the pressure is going to go down and the temperature is going to go down. Now as the pressure and temperatures go down, that steam is releasing this energy or releasing this enthalpy. And as the turbine releases this energy, it turns it into mechanical work. So the next component we see is the generator. So as with our wind turbines and our subsea turbines, we have a rotating component connected to a generator. So we have our steam turbine expanding the steam, causing mechanical rotation, and that rotation is what's turning the rotor within our generator. Now, as with our previous examples, if we use an AC generator, then we will be able to produce electricity at 50 Hz, providing our generator spins at 1550 RPM. Now there's a type of steam turbine called a back pressure turbine, which allows us to adjust the amount of steam exiting the turbine here. And what that means is that we can accurately regulate the speed that the turbine spins at. Now if we can release enough energy from that steam, it's going to return to water, but it's still going to be very hot water. And this is why we have a closed system, because what we don't want to do is lose the energy that we've already added to the water. Instead, we can have the hot water entering the boiler. It's going to take less energy to produce the superheated steam, and the cycle continues. So just to recap, we have coal on the left-hand side, which contains a huge amount of stored energy. When we combust the coal, it releases that energy in the form of heat, and we can use that to heat our working fluid, in this case, water. So the water then contains a huge amount of energy or enthalpy, but when we expand that steam through a turbine, it's going to release that energy. And that energy is going to be converted to mechanical work within our turbine. The turbine then turns the rotor within the generator, and we have our electricity produced at 50 Hz in order to be fed back into the national grid.